Hello and welcome to Exponentials 2.3 logarithmic function. So this is where it's going to start to get difficult, yeah? And it's going to get confusing because a lot of the stuff that we're going to be doing is going to center around properties of logs. Yeah, so we're going to start off with these four. Yeah, so 1, 2, 3, 4. And basically how you have to think of these properties are, think of it as substitution. Okay, and I'll give you an example of substitution that we've been doing pretty much our entire life in math. So if you ever see the problem 2 times 3 written somewhere on your paper, guess what that can be replaced by? Which in this sense is called substitution, right? It can be replaced by a 6. Yeah. Or if I have like 3 squared, right? I can substitute that by writing what it's equal to, basically, right? Because that's what substitution is, right? Plugging in something else in place of what you already have on your paper. So 3 squared, I can erase it, and I can sub in its spot a 9. Yeah. So these things, they don't look alike, but they're equal in value, and therefore we can replace something with another. Okay, so this concept of what I'm going to do in this section is familiar to you, but it's just going to be foreign in that sense. Yeah, it's going to seem weird in that sense because we're going to have all these things that we have to look for. So we're going to use these four properties to sub things in. Okay, so usually what you're going to see is the stuff on the left in your problem. So when you see these things on the left in your problem, you're going to see it replaced with like a 0 or a 1 or a letter, or sometimes numbers, and a letter here, or sometimes numbers as well. So you're just going to see it subbed in with whatever's on the right hand side. Yeah, so I'm going to erase all the ugly stuff with the word log in the problem, and you're going to see it disappear. You're going to wonder how did that happen, and all of a sudden like a 0 is going to take its place, or maybe a 1 or an x or some kind of number is going to take its place. Okay, so when that happens, you just got to remember, we're substituting, right? We're taking what we have in the problem and plugging in what it's also equal to, kind of like what I just erased on the side here, where 2 times 3, I replace it with 6. 3 squared, I replace it with 9. Okay, so that's kind of like the concept that's going to happen. So let's just jump into the first problem and you can start seeing it happen. Okay, so the first thing you want to do is you want to identify what part of these problems look like things in the list that we just came from. Okay, because all you're going to see is you're going to look for the left side of that equal sign. Yeah, so if you look at the left side of the equal sign, you're going to say, okay, which parts of this first problem do I see that looks like the left side of the properties that I have here? So you see these properties, so you see this whole left side right here? What problems or what parts of the problems that I'm going to be doing have these four elements in them, or one of these four, or maybe two? It depends on the problem, how complicated we make it. Okay, and the first thing I want you to do when you find it is I want you to circle it. So I'm going to circle the part of the problem that looks like the left side. Yeah, and I have two things right here. Okay, and I know I kind of went over the word L, or the letter L. So let's just get this first one. So this left side circle, which one of the four properties does this guy look like? 1, 2, 3, or 4? Okay, so look at the characteristics. We have a base 3, and we have a 3 inside the parentheses, or what I call the answer. So base 3, answer 3. Yeah, so notice how these two numbers match, right? They have the same exact number, so base and answer, those numbers match. So which property has both base and answer the same exact thing inside it? Okay, so this guy has base B, answer 1. Is this matching? No. This guy has base B, this guy has answer B. So that's so far so good, that kind of matches. But this guy too, he has base B, answer B. But this guy is different because he has power of X right next to the B. Okay, and this one is exponent form, so he doesn't look anything like the one that we're looking at right now, because this is exponent form. So the only one that the left side circle on the problem that we're looking at right now that it kind of resembles is property 2, where you got log, base B, answer B. So log of the same exact, I guess, letter or number in this case in our problem. Okay, and when we have the same exact letter matching here, or same exact number matching here, look what I can replace it with. I can replace it with the 1. Okay, so let's go back here and let's reference that this circle is property 2, so I'll put a number 2 there. Okay, and there's a 4 on the outside, so don't forget about that. So we basically have 4 on the outside, and this whole entire circle is going to get replaced with a 1. Okay, and we continue writing minus 2, and now we're going to replace that right side circle with whatever we are told to replace it with. Okay, so which property is this guy just like? So let's look at the characteristics. We have base 5, and inside the parentheses where the answer is hollow, we see 5 to the third. Okay, so this 5 and this 5 match, and then it has extra little power there. So which property looks like this, where it has the exact same base and answer value here in the parentheses, but this guy has an extra exponent? So which property looks just like that? So let's look at our list again. So we want to look for matching numbers. So matching numbers, yeah. They don't match, so don't look at him. Matching numbers, but does he have that extra power on the side? No. Matching numbers, or matching letters in this case rather, and a little power on the side. Okay, so when I have this property, so we have all come to the conclusion that the right side circle is this property right here. So when we have this property, look what it gets replaced with. It gets replaced with the x. And where does this x come from? Well, it comes from the power there. Yeah, so that x and that x are exactly the same. So when I have the same exact numbers or letters right here for the little tiny base and the number inside the answer parentheses, when these guys match, it gets replaced by the exponent, right? The exponent. Okay, so let's look at what we have. We have a 5 here, a 5 here. My power's right there, so guess what this entire circle is going to get replaced by? And join the -2 that's right outside of it, it's going to get replaced with a 3. So we're going to go times by 3. Okay, and this was property 3. Forgot to write that, property 3. All right, so we just do our math. We're going to get 4 minus 6, which is -2, and we're done. Okay, so the hardest part is you got to circle which part of the problem looks just like one of the properties on that previous slide. And once you can do that, you're home free. Okay, and I'll give you a hint. Usually the property that we're going to look at involves the word log, right? You don't have log in there, but you got to be careful not to circle too much. Like if I circle this 9, yes, I'm looking for the next one that I'm going to do. Let's go to problem B. So if I circle a 9, there's a number in front of the word log. So let's look at our properties. Does any of these properties have a number in front of the word log? No, no number, no number, no number. So that's why you don't want to circle the number 9 in that previous problem. You want to just make sure you circle the right things, because you really got to look at this list, and you got to say, my problem that I'm on now. Okay, first of all, which property does it look like? Yeah, after I make the right type of circle. Okay, so, oops, let's go the other way. So let's circle this part, and yeah, sorry, I'm hiding the L. Yeah, because the pen that I'm using is a little bigger. Yeah, so. Now let's look at what we have inside the circle. We have a base of 7, and inside the parentheses we have a 1. So are these matching numbers? No. So these two numbers aren't matching. So did we see a problem that had, or a property that had different numbers here and here? And if we did, which property was that? So we're looking for different things, right? Not matching things. So we're looking for the word log, so these 3 have logs, that's good. But these 2 guys have the same exact letter, B, B here, B, B here. This one is the only one that doesn't have matching letters or numbers, right? B outside here, 1 inside here. Okay, and is that the kind of property we have in this circle on that next problem that we're on? Yep, that's the one, because we have 7 as our base, and we have 1 inside the answer parentheses. So what is this guy going to get replaced with? So let's look. It's just to replace it with a 0. So this is the other confusing part that kids always get confused on. How come this guy got replaced by a 3 in our other problem, not an x? Well, like I said, this guy gets replaced by an x because his exponent right here was an x. So whatever this exponent is, that's what it's going to get replaced by. For these 2 properties, yeah, once we see matching letters or matching numbers here and here, we put them 1 automatically. It's a 1 all the time. Once we see not matching here, yeah, but we have to see a 1 in this spot right here. So that's the key right there. You have to see a 1. If there's no 1 in this parentheses, then we don't have that property. So it has to be a 1. Yeah, and the reason why it has to be 1 is I'll show you guys why. So let's change form. So keep in mind, this is base, this is exponent, this is answer. So we have B equaling an answer of 1. So what's the only way I'm going to get my value to equal 1? What kind of power can I put right here so that when I go B to whatever that power is, I get a 1 as an answer? Can I put 1 here? Is B to the 1 power equal to 1? What about 2? Is B to the second power equal to 1? No, the only number that I can use in the exponent that's going to make a 1 as an answer is I got to put a 0 right there. Okay, so you gotta keep in mind, yeah. So this particular property right here is it has to have a 1 in the parentheses. If it doesn't have a 1 in the parentheses, like if it has a 3 or something like that, like log base B of 3, it's not going to equal 0. The key to this property is it has to be a 1. Okay, for these guys, the key is these 2 numbers have to be the same, or these 2 letters have to be the same if it's going to be a 1 there. And if you want to ask me why that has to work that way, just switch the form again. So base B, answer B. So what's the only exponent that I have that when I put a number right here, gets B as an answer? If I put a 2, is B squared equal to B? No. If I put a 3 right here, is B to the 3rd power equal to B? No. So what's the only number I can put right here that creates a B? And that's where this exponent right here says the only number that's going to work is a 1. Okay, so as far as how these properties work and why they work, this is why they work. When you change the form and you switch it around to exponent form, it tells you why the 0 and 1 are legit answers. Okay, so that's if you want to know why these properties work, but not everybody wants to know that. Okay, but in case you guys did, just change the form for all of these 4 properties and you'll figure out how it works. Okay, or if not, if you don't want to figure out how it works, then just trust that if you see this scenario, put a 0. If you see that scenario, put a 1. If you see this scenario, replace it with whatever your exponent is, and so on and so forth. Okay, that's if you don't want to dive into how these properties actually work, like why they work that way. Okay, so if you just trust the properties that they say, then just put what it says. Okay, so this is going to be a 9 on the outside times a 0. Okay, then what do I circle for the next one? Okay, so this one's a little bit different. This one does not have log. Yeah, it has log in the power spot, but it doesn't have log down here, written in big letters. So, is that any one of our first 3 properties? No, because the first 3 properties all started with what? It all started with the word log written in regular size, not as not raised, not written tinier. So this is going to be the last property, number 4. So actually, I better write the properties, because I forgot to write it here too. So this is property number 1. Okay, so this is property 4. So let's look at property 4 in depth again. So property 4 says base B and base B here as well. So look at your bases. Base B here matches base B here. Yeah, so these two things match. And when this number and this number, or in this case, this letter and this letter match, yeah, with this whatever's inside the parentheses, look what it gets replaced by. It gets replaced by whatever is in the X spot. Whatever's in this parentheses, it gets replaced by that. Okay, so these last 2 properties, yeah, they're equal to X, which means that you can put actually any number in this spot that you have. It's just based on what number is sitting in this exact same spot. So same letter or number, same letter or same number, right? These guys match. You replace this whole left side with whatever's in the parentheses. Okay, and just like this one, matching B's here, or matching numbers, whatever it is, matching some things, it just gets replaced by the power that you just shove right there on the side. Okay, so that's the key to these last 2. So the first 2 are kind of similar. The last 2 are kind of similar in its I guess, the way it works. Okay, so we have matching 3's, right? So the 3's match. So we're just going to replace this whole entire circle with what's inside the parentheses. And what do you see inside the parentheses? I see a 6. So plus, right? Because that didn't get circled. And then 6. So we're going to have 9 times 0, which is 0, plus 6. That equals a grand total of 6. So there's your answer. Okay, good thing this is a video, so you can rewind it as many times as you need so that you can understand it. Okay, if this was live lessons, then yeah, you cannot rewind this, and that's why some of my kids, they get really confused, because I say it once or twice or 3 times, and maybe a kid doesn't understand it until like the 10th time to hear it. Yeah, so you're lucky, you can just rewind this video as many times as you need so that you can understand how this all went down. Okay, so good luck though on this part. All right, so let's move on to the next different set of problems. Okay, so let's move on to property 5. Okay, they don't really officially call this property 5, but I'm just going to call it property 5. Okay, so look what we have here. So we have something that looks just like one of the properties we had, but it's a little bit different. Yeah, so check it out. Does anything match at all? Do I see any letters that match? No, so this one is not based on letters that's matching. This one is just based on, we see something in a certain spot and we get to move it around. Okay, that's all this property is. So we see this P that's written right here is the power of X. Okay, and look where that P goes on the other side of the equal sign. Is the P right here anymore? Right next to the X? No, the P's all the way in the front. Okay, so this property is all about shifting a letter or a number, or a letter in this case in a formula sense, but when we start using it, it's going to be a number. So this is all about switching a letter, yeah, to a different part of the problem or the statement. Yeah, so notice how P is not here. Yeah, P is right here. P is the exponent of, P is the exponent of X. But when I write what this whole entire thing is equal to, this P that was my exponent can jump right to the front. Okay, so all this property is all about is shifting location, writing something in a different spot. Okay, and that's all this property is all about, just shifting a letter P to go to the front. Yeah, that's all it is. Just make the P go to the front. Yeah, so you're just changing the appearance. Yeah, by just writing this exponent P, in the front. That's all it is. Okay, and that's power property of logs. So let's see how this one works. Okay, so we see this 3, who is the power of x, right? The exponent of x. So I want to shift his location, just like in the property that I have on the previous slide, right? I want to make this 3 that's right now in a exponent position of the x, I want to put him in a different location. So when I rewrite this exact same left side of this problem, yeah, you're still going to see log base 2. You're going to see, you'll see an x inside of parentheses, but you're not going to see a 3 as the power of x. You're going to see the 3 in a different spot totally. Okay, and that 3 is going to go in the front. Okay, so you see the change? The 3 that was the exponent went straight to the front. Okay, and then I'm going to continue writing on the next part. So 4 log base 2 of x. Okay, so you see what just happened? All right, so notice how these two things are like terms. Yeah, so you have a 3, you have a -4, and think of this as like an x or a y or some kind of letter. Right, so if you see the exact same words and bases and numbers inside the parentheses, if you see the exact same thing that both of these letters have, you can call them like terms. Right, so both of them have the word log. Yep, they both have the word log. They both have base 2. They both have parentheses x, parentheses x. So you can consider this like terms. So all you have to do is go 3 minus 4. And what do you get when you go 3 minus 4? You get -1 log base 2 of x. Okay, so basically what this allowed us to do was, because this 3 got moved to the front, we now have like terms, right? Because in the beginning of this problem, these guys are not like terms, because this guy has a 3 right there, right next to the x. This guy doesn't, so they're not like terms. But me being able to shift the 3 to the front via the property that we just worked on, property 5, okay, it allowed the two, I guess, ends of each number, right? Log 2, parentheses x. It allowed them to now match. Yeah, and now that they can match, they're considered like terms. We just got to go 3 minus 4, we get -1. Okay, and we got one last part of this problem to do. Okay, so in your instructions it says, if you ever see this thing called log base 2 of x, right, this thing that I'm circling right now. So if you ever see this thing called log base 2 of x, what are you allowed to replace it with? So what does it say? It says log base 2 of x is also known as, or equal to, 4.1. So let's replace this entire thing with what number? 4.1. And when I do that, I get -4.1. And that problem is done. Okay, so you see how that went down? Okay, like I said, lucky this is a video. You can watch this as many times as you want. Okay, all right, so let's work on letter B. All right, did I change the color? Yeah, I think I did. Okay, so same thing here, right? We see this y, he has a 4 as his power. So we're going to use power property of logs, and we're going to make this 4 go all the way to the front. So this property rather, like I said, is all about changing location. Okay, the other 4 properties that we worked on, those are all about substituting, replacing. Okay, this one's all about changing location. Okay, so you see this 4 is going to go all the way to the front. So we're going to write 4 log base 3 of y. Okay, wow, my wrist is really putting on some random marks here and there today. Maybe because it's hot today, I don't know. Okay, and what about the next guy? Does that guy have any property 5 to use? Does this guy have a power that's going to go to the front? Actually, you know what happened? This guy has a 6 in the front already, so guess what happened to him? We already did the power property of logs on this guy. Yeah, because this 6 that's in the front, he could have been written right next to the y, but we already did power property already. So, in a sense, yeah, that's just one less thing for us to do, because his 6 is already in the front, just like this 4 was moved to the front based on the property that we just used, right? It was as the power of y, we moved him to the front. This 6 is already here, so we didn't have to move him, so that's just one less step for us to do. So thank you very much for not having us do 2 things in this problem rather than just 1. Okay? Alright, so let's check what we have. So are these like terms? Do they both have the same exact set of words and letters and numbers after the number, right? So is whatever's after the 4, whatever's after the 6, are they matching? Because if they are matching, they're like terms. So let's check it out. This guy has the word log. That guy has the word log. This guy has base 3. This guy has base 3. This guy has parentheses y. This guy has parentheses y. So can we consider these guys like terms? Yeah, of course you can. So since they're like terms, you just do what it says, do to the number. So it says 4 plus 6, which is 10, and then log base 3 of y. Okay, and then let's look at our instructions, because it says over here in the instructions, look at what I'm circling in purple. It says if you ever see log base 3 of y, what are you allowed to replace it with? You can replace it with 5.3. So this is not a property, yeah? Okay, so don't get me wrong now. This is not one of the properties that we saw in our list earlier. This is just pretty much straight substitution. It's just telling us if we ever see this log base 3 of y in our problem anywhere, put 5.3 instead. If we ever see log base 2 of x, put 4.1 instead. So they're just telling us what to substitute. Okay, it's like when they say in a problem, let x equals 5, and then solve for the problem. Yeah, so that's kind of like what it's saying here. So it's saying if I ever see this, replace it with 5.3, and this is exactly what I have in the purple circle in my instructions. So I'm about to replace this entire circle right here with a 5.3, and then that's going to get multiplied to 10, and when I do that, I get 53. Okay. Alright, so I'll let you guys digest that, but like I said, this is a video, so I'm just going to continue on without stopping. Okay, so best way I can describe this is back when we did variables, you guys were taught that there's certain default situations that can apply. So if I just have the word or the letter x here, for example, how come it's not writing? So if I just have the letter x like this, what power can I assume is associated with that x? And this is where you say 1. Yeah. Do I have to write the 1 there? No, because if it's written there, if it's not written there, we can assume it's a 1. Okay, just like the letter x. Again, okay, what number is right in front of this x that I know is there, but I don't have to write? Well, there's a 1 right in front of the x. I don't have to write it, but I know it's there. Okay, or what about square root? Yeah, the radical symbol. What number is inside this little tiny spot right here? I don't see any number. Do you know what number is supposed to be there? Well, it's supposed to be a 2. So why don't I write a 2 every single time I write the square root symbol? Because that's your default number, right? And these default numbers, yeah, are invisible basically, but we know it's there. So we don't have to write the 2 there if we don't want to. Like we don't have to write the 1 here if we don't want to. We don't have to write the 1 here if we don't want to. Okay, so this statement right here, yeah, this statement right here says my base is 10. Notice how it doesn't say base 10 here. So if I ever see the word log by itself, like log and it's just a number in the parentheses, if I ever see just this by itself on a problem, you know what number I can assume is the base? I can assume 10 is the base. Okay, so if I don't see a number, a little tiny number written right here, right next to the G, right before the parentheses, if I don't see a little tiny number right there, my assumption is it's base 10. Okay, they don't have to write base 10 in tiny little numbers. If it's not there, it's going to be assumed that it's 10. Okay, and that's what you want to get out of this statement, that the assumption is base 10 if I don't see a little tiny number written right there. Okay, all right, so next thing, change a base. Okay, so unless you have a really fancy calculator. Okay, so if you have one of those fancy calculators, here's what your calculator is going to do when you hit the button called log. On your screen, it's going to have this. Okay, right away, you're going to see this on your screen. If you have a fancy calculator, when you push the button log, it's going to put the word log on your screen, then it's going to have 2 boxes. Okay, and in this box, you can use your right and left keys so that you can put whatever number you want in this box. Then you hit the right and left arrow key again, you can put whatever number you want in that box. Okay, so that's for the more advanced calculators, the calculators that are a little bit more expensive. Okay, so if you don't have a fancy calculator, you have to use what is called change a base formula. So this is the way the book writes the formula. Okay, I don't write it that way. Here's how I write the change a base formula. I go log of answer divided by log of base. Okay, so me with words, I tend to understand formulas that have words more than just letters. It's easy to memorize because I know what answer means, right? It's the number inside the parentheses. I know what base is. That's my little tiny number next to the G. So if I know how to remember the formula, then I'll use it hopefully correctly. Okay, and why do we need this formula again? Well, like I said, if you don't have an expensive calculator, you cannot just put in whatever number you want right there and whatever number you want right there. It's not going to give you guys this format when you guys push the word log. It's just going to have the word log without these 2 boxes. Okay, so if you have one of the cheaper calculators, which is what most of us do, yeah, then you have to do this. You have to go log of whatever number's in the answer spot divided by log of whatever number's in the base spot. Okay, so it's kind of like you're able to tell the calculator what to do by doing simple programming. Okay, that you're able to let the calculator do a job, yeah, a calculation that it wasn't meant to do. Okay, so just like if you didn't have the button for squared, right? Can you easily get around, like, let's say if I had 4 squared. Yeah, so if you didn't have a square button on your calculator, can you easily get around this fact that you don't have a squared button? Yeah, you can. You don't you type in your calculator instead? You type 4 times 4. Yeah, and you get the same exact answer. So just like this, if I have a button, if I have a calculator that doesn't let me have log with 2 boxes, there's a way I can get around it. I can just do log of answer divided by log of base, and I'll get the same exact number as the fancy calculator does. Okay, so just like this, 4 squared is also known as 4 times 4. I don't need a calculator that has a squared button. I can still get the answer. All right, so let's use this formula. Okay, so what they have is log base 7 of 52. Okay, so if you have a fancy calculator, yeah, you can use your fancy calculator and put whatever number in the box you want, but I suggest you actually learn change of base formula. Okay, because what if one day you forget your fancy calculator at home, and then you have to borrow your friend's calculator that's not as good? Then you're going to remember, oh darn, I don't have that button that makes me put whatever numbers I want in a small box and a big box. Then what's going to happen at that situation? Or you're going to get it wrong. Okay, so whether you have a fancy calculator, whether you have a cheap calculator, yeah, do this formula so that you know it. Okay, so how do I set this up? Well, I go log of 52. You can put parentheses or not, doesn't matter. Divided by log 7. And when you punch it into your calculator, you're going to get 2.03053. Okay, so your instructions say round to how many decimals? Okay, it says round to 4 decimals. So I wrote 5. So why did I write 5 when it says round to 4? Well, the 5th decimal 3 tells me what to do to the 5. Do I stay at 5 or do I become a 6? Well, the 3 says stay at 5. So your final answer is 2.0305. Okay, and make sure you round, people. Okay, I'm not going to accept unrounded answers. Yeah, other teachers may say rounding is optional, but that's not optional for me. Okay, you need to round. All right, so let's look at our next one. So we're going to do log 4.2 divided by log 2.5. Okay, and when you punch that in the calculator, you're going to get 1.56618. So that's 5 decimals. Like I said, I wrote 5 because I want to round to 4. So the 8 tells me keep it a 1, or does 8 tell me turn it into a 2? Well, hopefully you said 8 tells you turn it into a 2. And if you said turn it into a 2, good job. You got it correct. Okay, so that's it. Sorry this video is kind of on the longer side, but logarithms, yeah, they get kind of crazy. Yeah, so watch this video as many times as you need. Yeah, and I'll see you next time. All right, bye-bye.